In today's video, I want to show you how to use behavior trees. In order to get there, I'm going to have to do some setup first, so I'll include a link in the description that takes you right to the discussion of behavior trees. My idea here is to make a game of tag, so I will be one player and I need to tag the other players, and well, you all know how tag works. Now, one of the tricks to making a good game of tag is to have the rule no tag backs, which means once you are tagged as it, you cannot immediately tag back the person who tagged you. So let's get into the third person template and start modifying it to allow for simple rules for game of tag. So I'm going to start by duplicating the default character, and I'll call this BP tag character, meaning a character in the game of tag. Then I'm going to do something maybe a little bit unintuitive. I'm going to take the third person character here and reparent them to the one I just made. So my idea here is that the player controlled character, who I'm going to rename as BP tag player, is actually a specialization of a more generic tag character. This tag character doesn't have any of these input needs, will be controlled by AI, so we don't need any of that, and also doesn't have a camera boom or a follow camera. So now I have a more generic tag character, and I have a more specific BP tag player, who of course has things like cameras attached to him. So even with just this much here, I can go in and just throw a couple of extra players into the game. Good. And of course if I play this, nothing interesting happens except that I can move my own guy around. So let's add in some logic to keep track of the fact that somebody is it, and a random person is chosen as it at the start of the game, and when they tag somebody else, they become it. So the game rules like that, I want to put into the third person game mode. So although once again here, I think what I want to do is rename that to follow the usual conventions that my students and I use. We'll call this tag game mode. Good. So in the tag game mode, I'm going to keep track of who is it, and the type of this variable can be a tag character. I also need to know who was previously it, so that's the player who's currently immune from being tagged. So we'll just make another variable, and we'll call this previous it. That's good so far. So at the start of the game, let's go through all the different tag characters and choose one of them to be it to start the game. So let's see, what we'll do is on begin play, we can find all actors of class, and the class I want here is tag character. Remember, that will be my AI characters, and it's also the superclass of my tag player, and so this will capture him also. If I wanted to be really fancy, I could randomly select from this array, but for the sake of simplicity and keeping the video from getting too long, we'll just take the first one. And we'll say that this person is it. And we simply won't have a previous it. Alright, so that's good for now. It's going to be really helpful for both gameplay and debugging purposes to have a different way of representing in the game who is it. So what I want to do then is go to my tag character, and we'll set this up so that he periodically polls to see if he's it or not, and if he is, he can change his color. So knowing we're going to do some color changing, the first thing I'm going to do is make a dynamic material instance. Now, since I'm working off the third-person template, I have this asset called UE4 man body, the mannequin body, and if we take a quick look at that, we can see that it already has a parameter called body color. So I'm going to make use of that. I don't need to write that from scratch. That's not where I want to be. Here we are. I don't think I'll need that at all, so we'll close it. All right, so that'll be the body. Let's store a reference to this, and we'll call this the dynamic material instance. And we'll also set, well, we don't need to necessarily set its initial value, because what we can do right away is set up this interval that checks every couple of milliseconds and sees if I'm it or not. So I'll do that with a task. Set timer by event, that's what it's called. It's not a task, it's an event. There we go. And this will be looping, and we'll just have this check every 5 times a second maybe, or we could do 10 times a second, that's fine. And we'll make a new custom event here, and this will be called check color. Check and update color, perhaps. All right, so from here we need to know what the game mode is, and from the game mode we need to know who is it and who is previously it. So maybe a nice way to do that would be to get a handle on the game mode and do the casting once rather than having to do it every time we run this event. So let's make a new variable. Here we can say get game mode here and cast that to tag game mode. We can make this pure cast, and then we can promote that to a variable, and we'll call that tag game mode. There. So now we only have to get that and cast it once, and then we can reference it from within this timer. All right, so what do we need to do? First, let's check to see if the current character is it. So that means we can grab the game mode and say get it. Here it is. And ask to see if that is the same as self. There. So if I am currently it, then we'll set that material to a particular color by setting a vector parameter. Of course, we need a little bit more room here because we need an if. Okay. So if it's the case that I'm it, we'll set this body color to be, well, let's go ahead and make this a variable too, because then we can call it color. And if we compile this, we can set its value to be, let's say, a nice shade of red. Good. Now, there's 3 different colors that I'm going to need here. The color if I'm it, the color if I'm previously it, and the color if I'm anybody else. And I know this is going to get a little bit ugly, so one thing I'm going to do is take these and collapse them to a function, and we'll call this set color. That way at least I don't have to send that dynamic material around at all, because it's always the same, right? It's always the value of that variable. So that's good. We'll just verify this is doing what I want here. Yeah, that looks good. Although value isn't a very good name there. Let's call it color. And back out to here. All right, so now we can say that's the game mode. Who is the previous it? And ask if that's myself. All right. So if that's me, then I'm going to set my color to be, again, I'll use this promote to variable, and we'll call this the previous it color. And just straighten this out a little bit. Compile so we can set the value, and we'll make this yellow. And finally, in all other cases, we'll just set to a default color. And we'll call this default color. And compile. And make this a nice shade of gray. Good, that should do it. This looks like it should be commented. So this will be update my color based on whether I am it, previous it, or default. Good. We could take these things and put them in a category too if we wanted to. We could have a category called colors. It's just a matter of keeping things tidy. So, all right. Let's see, did we add the logic yet to set somebody to be it? Yeah, I think so. So if we play this, well, nobody is it yet. Oops, good. We can get some errors and see what went wrong. So when we're asking for tag game mode, oh, yeah, I never actually set the game mode, did I? So let's go to the map, world settings, and set it to BP tag game mode. You may recall that I renamed the default game mode to be BP tag game mode. I've noticed that when you rename game modes, they actually get disconnected from where they're attached to levels. That's pretty inconvenient for people like me who like continuous refactoring. But at least once you know that happens, you can watch out for it. Okay, how about now? Nope, nobody's it. and no errors. So let's just walk through again and see what we have. Make sure I got all the pieces together. So on begin play, we set this material instance. It's stored here. Oh, we never actually connected this material instance to the mesh. So let's pull this back a little bit, and we can say set material for the mesh, right? It's important if we want to see an effect of a material to actually use that material. Good, and then we're getting the game mode. And again, this is getting a little bit ugly. Good. Yeah, there he is over here. That guy's it. Now, of course, there's no behavior to say he tags people and turns them into it. Let's go ahead and add that. So make sure everything's saved, and in the viewport here, I'm just going to add a little box collision component to the front of this guy, and that'll be sort of his range of who he can tag. And it turns out life gets a little bit easier if I don't make this overlap that capsule, because otherwise it's going to generate a collision. So let's just shrink this up a little bit and stretch it in case we're dealing with jumping or ledges or something, and then just line it right up there. That looks good. Alright, so when that component overlaps something else, here we are. I think what I want to do here, because I have the game mode handling the tag logic, is just hand this over to game mode. So let me stub in game mode a new custom event called tag. And you know, sometimes when I'm stubbing things in like this, I'll just throw in a print string so I don't forget, right? Sometimes I start moving in multiple directions at once and it's easy to get lost. So when we get a call to tag, there's two things we need to know. That's who was the tagger, and we know that'll be a tag character. And then who did they tag, or whom did they tag? We'll call that the tagged. And that looks good. Good. Back over here, so we can say when that box in front of a character overlaps another character, then we should be able to say get the tag game mode and call our new custom event tag, and we'll say the tagger is self, right? That's this actor, and the tagged is the other actor, which is only known as an actor, so we'll just cast to tag character. Now, of course, if this tag fails, nothing's lost, because we'll only execute the tag if this is, in fact, a tag character. So, there. It's a little bit ugly, but I think we'll get by. Good enough for a video. Good. Okay. All right, let's save that and run it. So, of course, we haven't added any behavior yet, but that guy is red because he's it. And if I run into that collision box, you see why I add that print string. Good. Back over here. So, we only care about a tag if the person doing the tagging is it, and the person they have tagged is not the previous it. So, we can say, is this person it? There we go. And then I can say if that's true, that that person is it, and the person they ran into is not the previous it. So let's just use not equal previous it. Now, remember when we first start the game, previous it has no value, but that's perfectly safe here. If previous it is null or none, then this comparison is still valid. We don't need to explicitly check to see if this is valid first. So now we can say, let's see, I am it, and the person I'm tagging is not it. Okay, that'll be here. So what I want to do, let's first update our state. We can say the previous it is going to be whoever was it, and the new it, oh, that's awkward, we'll do it this way, is going to be the person who is tagged. Right, the previous it is the current it, and the new it is the person who was tagged. Now that's a little bit ugly, so let's just use the old double click to add a reroute node and just pull that out a little bit. There. It's not perfect, but good enough, hopefully, for my debugging purposes. And that's really all we need to do here, I think. Let's try that out. Okay, that guy over there, I should move him a little closer. Alright, something is wrong here because I'm running into that box and nothing is happening. Well, we didn't get any errors, so let's see what we can check here. We know that this was getting called. Check that the tagger is it. That's true. Oh, I use the not equal here, so this should be true. It's true that that person is not the previous it. That's better. Let's move that guy closer. Remember that I'm just setting this kind of arbitrary person to be it, and it's going to be this guy every time. So bring him a little closer. Good. Get it over here. There we go. Now I am it, and he is previous it. So if I run into him, nothing happens. And I'll go find this guy and tag him. Now he's it, and I'm the previous it, which means if I get in front of him, nothing happens. And now we're at a good point to start adding the artificial intelligence. So let's get back to here. What I'm going to do is rename this to tag. My teams use a naming convention where we keep all of our top-level blueprints in a folder named after the project, so that works well. And then we get into blueprints here. Good. All right, so there's going to be a couple of pieces of plumbing we need to do to get this to work. One thing we're going to need in several steps is a nav mesh. So I'm going to do that here before I forget. So I'm going to find navigation mesh bounds volume, drag that into here. In order to do any kind of pathfinding, we need to have this nav mesh set up. So what I'll do is I'll just go over here and put it at about 12 by 12 by 12, which pretty much covers this whole area, and put the origin at the center. And yeah, it's not perfect, but good enough. Maybe a little bit larger. There. The height is overkill, but that should get most of the playable area. If we press P, we'll get a preview of where the nav mesh bounds currently are. So that looks pretty good. This will be our playable area for the game of tag. Okay, so that's done. We'll save that. I'm going to also need an AI controller. So start by making a new AI controller blueprint. I'll call it BP tag AI controller. And we need to tell the tag character that that will be its default AI when it's possessed by an AI. So instead of regular AI controller, be tag AI controller. Alright, so far we won't see any changes in the game, but this is just some plumbing that we need to make things work. So now let's start adding the artificial intelligence pieces here. We're going to make a behavior tree, which I'll call BT tag AI, and it needs a corresponding blackboard, which I will call BB tag AI. BT for behavior tree, BB for blackboard. And by default, these things should be linked together. If I click on the root of my behavior tree, yep, it's using the tag AI blackboard. Good. So all of this stuff that I'm going to be doing with the behavior tree is all doable within either C++ or Blueprint without using behavior tree. The behavior tree is a convenience. People creating games realized that behavior trees are a concise and expressive way to program artificial intelligence, and the particular engineers at Epic came up with this manifestation of the idea of behavior trees. So broadly speaking, our rules for the AI go in the behavior tree, and the blackboard serves as sort of a memory. Each individual agent by default has its own blackboard, and the blackboard contains the variables that the behavior tree will be accessing. So let's jump right into it. At the very basic level, an actor needs to know whether or not it is currently it in the game of tag. So I'm going to pull down a sequence node here, and I need a service that will continue to run and check to see if this it has changed, if the fact that this current agent is it or not has changed. So That's what the service is for. A service is a process that runs intermittently and watches for some global condition. Um, a task, by contrast, is a discrete thing that you run and then finishes. A service is periodic. So I'm going to make a new service. By default, services have this horrible name. I'm going to rename this to BT service check who is it. There, and over here that should link up. Okay, yeah. So check who is it, and I'm going to add that. Actually, what I want here is a selector, not a sequence, and I'll talk more about that in a little bit. We're going to add the service here. Check who is it. So what this service is going to do is watch the game mode and let this agent know whether or not it is it or not. The way that it knows that is through the blackboard. So I'm going to need a new key here. We'll use a Boolean. Oops. There's a weird usability error where the first time you open up the behavior tree and link it to a blackboard, this doesn't work. But if you close it, go back and reopen it, then it's fine. I've had this happen at least on Windows. I don't know if it's on other platforms too. All right, where was I? Blackboard. New key, Boolean, and I'll call this I am it. Because it is an awfully short variable and this is a little bit more expressive. We're going to say that this is a Boolean and that should do it. So again, remember the blackboard, it's like the working memory of the behavior tree. And so this service is going to be what goes out and checks to see if I'm currently it or not. So if I go to the overridable functions, we see one called receive tick AI, and that's the one I want here. And this is not like a tick in a blueprint where it runs every frame. This only runs when the behavior tree decides to update the service, which is actually configurable over here, right? This is running about twice a second with a little bit of random deviation. So over here, we can say, we can ask the question, am I currently it? And so let's get the game mode, because game mode knows. Cast it to tag game mode, and this may as well be a pure cast. And we can say get it. Okay, so the question is the game's current value of it the same as this AI? Well, the nice thing about this receive tick AI is we get a controlled pawn parameter, which tells us which pawn is controlled by this behavior tree at this time. So we can again just do an equals check here. Are they the same? All right. So based on that value, I want to update what is in the blackboard. So remember, I have this key called am I it. So I'm going to go over here and I'm going to say set blackboard value as bool. Now this part gets a little bit weird. It takes some getting used to. We need a key, and this is sort of a name variable. Those of you who are programming language wonks might enjoy thinking about what that means in terms of the runtime system. I want to focus more on just the pragmatics here. I'm going to call this I am it because I think that's what I called it over here, right? But right now these two things are not actually connected. So let's go and look at the behavior tree. What I'm looking for is something that's not there, which is awfully hard to show you, but look at what this looks like. And then we'll go back over to our service and expose this variable, compile it, hop back over here, and now we see it maps from the services key I am it to the blackboard key I am it. So that's what this means here, is that it's taking the variable that's local to that service and mapping it to this blackboard variable. So now, twice a second, right, about every 0.5 seconds, this blackboard is going to be updated. For the purposes of gameplay, I think I want to do that a little bit more rapidly, so we'll do it 5 times a second. It's a very cheap operation, so I'm not worried about that. Okay, so once we know who is it, we can do something with that information. What we want to do is find a target to move to and move to it if we are it. So let's add a task. Let's add a sequence here. And again, once I get this all laid out, I'll say a little bit more about selectors and sequences, but for the time being, bear with me. Again, the sequence has 2 parts. Find somebody to go tag, and then go tag them. So As I'm working on this, I'm remembering there's another piece of plumbing that's going to cause me some trouble if I don't remember to do it. And because I'm remembering it now and I don't have the advantage of a piece of paper to write stuff down on that you can see, I'm going to make sure I deal with this right away. I'm going to go back to my AI here. And I want to make sure that when we begin play, we're going to be using a Blackboard. This is why we have this AI subclass, by the way, why we subclassed AI controller. We need to tell this we're using BB tag AI, and we want to tell it to run a behavior tree. Which behavior tree? Of course, that one. Now, that's a little bit of a sanity check because I know, if I forgot to do that, later on things wouldn't work and then I'd get awfully confused. So, a little piece of plumbing there. All right, back over here. First, find a target. Now, if we pulled off of here, there's all sorts of tasks that are built in, but there's not a built-in task, specifically for our game, so we'll make a new task to do that. We'll make a task, and also this has a terrible default name here, so we'll call this BT task find target to tag. Tag is better than gag, and good. Here we are. Now once again we'll go to the overridable functions and we can say receive execute AI. So the idea here is that the task is told to run, to execute, and when it's finished we actually need to call a node called finish execute. That'll come at the very end. So the task begins and the task ends. And again, that's in contrast to the idea of a service, which is a periodic polling. Okay, so how do we know who we want to choose to tag? Well, there's a couple of ways we could do this. Maybe what we could do is try to find the closest person who's not it. So let's get the game mode, because again, game mode knows everything about who is it, and we'll cast this to tag game mode, and we'll make that a pure cast, and let's go ahead and make that a local variable, which we'll call tag game mode, because we'll probably need that a couple times. Maybe that's premature, but it seems like we're going to need that. Then I want to say find me all the other actors. So let's just do that. Let's say find all actors. What is it? Actors of class. Get all actors of class. Here it is. And those actors will be any tag character. Alright, so this will allow us to iterate through them, but we only care about the ones who are potential targets, which means they're not currently it, and they're not previously it. So let's see. That sounds like the kind of thing that maybe could be a handy utility function. So let's go ahead and make a new function. We'll call it is possible target, and we need to know a tag character. I'll call that character. That's an input to it, and the output will be a Boolean is possible target. Okay. So how do we know if somebody is a possible target? Well, let's see. Game mode is actually in a different scope. That's all right. We'll refactor it later. So again, get game mode. Oh no, it's not. It's yeah, it's in the class scope, instance scope rather. So here we are. We can get that, and we can say get it, and then we can ask, is that character it? So somebody's a potential target if they're not it and they're not previous it. Maybe this is easier to say in the negative. So I'm not it and not previous it. Yeah, that looks good, I think. Time will tell, I suppose. The proof of the pudding is in the eating. Here we are. All right, so somebody's a possible target if they're not it and they're not previously it. Good. So back to the event graph. We can say about this guy, is he a possible target? Oops. Is a possible target. Gee, another option would be to make that into a macro, but let's just go ahead and move forward with this. Okay, if that person is a possible target, then we could look for the closest one. We could choose an arbitrary one. Maybe we'll look for the closest one. So let's make a new variable called min distance, and this will be a float, and we'll give it a very large starting value. And then over here we can ask how far is that character from where I am. Now this is going to get a little bit messy, so let me preempt that by making this a variable called current element, because then instead of dragging those blue lines all over the place, I can just say I can get that current element and ask the distance from it to do the same thing over here. Promote that to a variable called the controlled pawn. Yeah, rather than drag these lines all the way across the blueprint, we'll just hop over here. All right, so is the current element, sorry, distance, get the distance. Get distance to who? The controlled pawn. Is that value less than the minimum distance we've seen so far? If so, it's a potential target. We say, is it closer than anything else we've seen? If so, we'll set a candidate target candidate, which will be a tag character. Good. So we'll set, whoops, except I want to actually set that value. By the way, holding Alt to get the set automatically. Set target candidate to be the current element. And again, grab that over here. This is a lot like having a local variable inside of a function in text-based programming, right? It's a convenient way to avoid having a lot of messiness in your scope. All right, so that should do it, so that after going through this loop, current element should be the one that I'm closest to, which means at this point, right, I've completed the loop. That target candidate is the one I actually want to chase down. So we need to have a way for the behavior tree to know that. What does that mean? It means a new Blackboard key. So back to the Blackboard, make a new key, and we'll make this be an object, and this will be the target actor. I'm going to do a little trick here that's going to make life easier for us, which is, you notice the key types are, there's only a fixed number of these types here. We don't get access to all the different types that we've created. That's because of the way that the behavior tree system is implemented. But when I use object type, I can set a parent type. So I can make that actor. I could also make it something like tag character, which of course is a subclass of actor. And that's going to make my life a little bit easier when I try to follow this guy. Okay, so that looks good. Now remember, over here, yep, that's the right place. What we want to do is say set Blackboard value as object. What value do we want to set? It is the target candidate. And the key, I'll promote that to a variable, and again call this target actor. I've seen some people recommend calling it target actor key in order for you to know that this key should map to another key. I've seen other people prefer to just name it so that the name matches the Blackboard. So as you're reading code, you might see both of those conventions. This seems to work pretty well for me. So let's go back to, this is the last step. So let me go ahead and finish execute. Right, because that we have to call finish execute when we're done with the task, right? And this is going to be a very fast task. We go through all the actors, we look for the closest one, we set the Blackboard, and we're done. Good. But we must not forget two things. One, this is my Blackboard key selector. Make that visible, which allows us to go back to the behavior tree, and we can say, what do we call that? Find target to tag. Now, notice there's something interesting here. Target actor inside the task is mapping to completely the wrong Blackboard key. But there we go. The types didn't even match up. I'm kind of surprised it doesn't, filter those out. But that looks pretty good. So let's remember what's going on here. We're starting at the top of the decision tree, the behavior tree rather, and we come in here and we say, start up the service that says who is it, and then the first thing we're going to do is find someone to tag. All right, what are we missing there? We only want to do this if I am it. So that's where we use a decorator on top of the sequence. So I'll right click and say add decorator. It's a Blackboard decorator. What condition do I want? Now it turns out it by default picked the right one. I want I am it to be true. And that looks good. So that'll find us a target. Now let me show you something interesting. The next step is really quick, but I want to show you a neat debugging tool. So if you go to play the game, now we don't have anybody following anybody, right? But if the behavior tree is working right, that guy over there, the red actor, should have chosen somebody to tag. In fact, probably the player because he was closest. So I'll use Shift F1 to release my mouse. And then I can, here, let's see who this guy is. Whoops. Eject. And click on this guy to see who he is. He's called tag character. If we go over here, we can choose different characters and see what the current state of their behavior tree is. Isn't that neat? So right now we see that this is actually kind of going nuts here. It's rapidly going in and seeing yes, I am it. Yes, I have to find somebody to tag, and then it just keeps on doing that. Obviously we need a little bit more behavior. So we can do a nice move to here. And move to is the node that required the nav mesh, by the way. If we didn't have the nav mesh, this wouldn't work. And by default, it actually grabbed the right Blackboard key, because remember the Blackboard is like the working memory. Let's save that and run it and see what happens. Oh man, I thought for sure that was going to work. Let's debug it. All right, well let's do that. Let's do that trick I showed you already. Let's go to the tag AI. We can see if we choose the different controllers. What I'm doing is I'm scrolling through these and looking to see what these values are. So here, I am it is set to true. Target actor is still none. So somehow we're not getting that target actor specified properly. So let's double check the logic there. So we can see that our mapping is right. We have target actor being a target actor. And if we double click here, we can go back to that task and just double check our logic. So for each loop, we're going to go through and say, haha, do you see what I see? Nobody's attached to that. All right, so who is this? It's the current element. There. How about this? Here he comes. He's got me. Then he keeps on running. That's an interesting problem we're going to tackle in just a moment. But for now, if I go up here and grab this guy, he's it. I'm previously it. He finds a target. He goes and tags him. No tag backs, right? He's come to get me. Fun. Well, I don't know. I guess maybe I have a low bar of fun, but you know how it goes. You play with Unreal Engine for a while and something works. Yeah, rejoice a little bit. All right. I think that calls for a little sip of tea, in fact. All right. So let's go back over here and look at how we can add some behavior to the guys who are not it. I want to have them sort of run around. So let's talk about selectors and sequences. Every time we run the behavior tree, we run from the root by default. And we fall down into the next node, right? Follow the downward arrow. This is a selector, which means it's going to run its children until one of them succeeds. When one of them succeeds, it's done. Okay? So let's see, what does that look like if we play the game? Let me go ahead and get myself tagged as it, because that means nothing else will be changing. So here, right, all these guys, nothing's happening. Right, because this condition is failing. See the little red line there? This condition is failing. None of them are it. So the selector goes down here. It sees, it tries that. It fails. Nothing else happens. Okay. So if we add another node over here, this will be the alternative. That if this fails, we go over and do this one. Now it turns out this is one that we only want to do when I am it is false. All right. Good. So what do we want to do if we're not it? I think what we want to do is just have them run to a random location, because That's pretty easy. So I think the best way to move forward is just make a new task. And once again, I'll go in and give this a better name. We'll call it BT task. Um, choose random location. And this is a task, so I can override the execute AI. And there's a node called something like find random navigable point. Yes, get random point in navigable radius. Perfect. Starting from where? Starting from wherever this guy is. So we can say get your transform. No, we don't need the transform, we just need the location. So let's get the location. That's where we're going to search from. And again, this is one of those features that needs navmesh up and running, but we have navmesh, so that's good. What's our radius? Oh, we'll just put in a big number here. That should be fine to cover a playable area, I think. If not, good enough for demo purposes. Now, we get this location. What do we do with it? Once again, this is our brain, this is our logic, but we need to have a working memory. So, go to the blackboard, make a new key, and we'll call this vector, and this will be my, what do I call it, target location maybe? The place I'm going to go when I'm not it. In fact, that's a good thing to document. Good. And we can call this one the actor being chased down for tagging. Good. All right. I get so excited with names, I forget where I was. Let's see. Choose random location. All right. What do we do? Right to the blackboard. So set blackboard value as vector. Good. And set our key. And what will we call this? Again, I like to just call it target location. That looks good. And don't forget, we're in a task. Got to finish execute and say this was successful. What does that success mean? Well, remember how this works, right? If any of these nodes fail, that'll change how selector and sequence works. Selector is going to go through and run its children until one of them succeeds. Sequence is going to run through them until one of them fails. Right? Sequence is going to do all the children. We could make this return false, make the task return false in order to abort the sequence. All right, so we have choose random location. Good. Now once again, back over here, expose that key. Go over here and make sure it is mapped to the right blackboard value. Good. And again, just to make this very clear, the names don't have to match, right? I don't need to call this target location inside of here, but it sure is convenient because then these get a one-to-one mapping. It's very easy to see what you're dealing with. All right, so in the case where I am not it, I'm going to choose a random location and then move to it. Once again, move to helps us out quite a bit, but instead of target actor, we're going to move to the target location. All right, let's see what happens. Hey, look at him go. Now I am it. Now there's one other thing that you may have noticed and may not have. It's actually a little bit harder to see when they're all running around like loonies. So let me just momentarily break this and run it again. Do you remember how after this guy tagged me, he went on running to somebody else? Let's see if we can get that to happen again. Yeah, there you go. See, the yellow guy, he was it, and he tagged the other guy, and he kept on moving. We say, well, why? Why did he keep moving? Well, because that's exactly what the behavior tree actually is telling him to do. It says find somebody to tag and move to it, but that's regardless of the fact that I'm currently it or not. What we want to happen is when my state of being it changes, we want to reevaluate the behavior tree. So let me show you how we can do that. And this is one of these things that, there's some great videos giving tutorials of behavior tree from a couple years ago, and the UI has changed and the default values have changed. And so it can be a little difficult to find the right information. But here's what we want here is observer aborts. right? Those of you who know good object-oriented programming principles know the observer design pattern, where you have one agent that's watching another one for changes. So this Blackboard-based condition is an observer. It's watching this I am it. But by default, if I am it changes, it's not going to stop doing the move too. It's going to keep on moving. But we can say abort self. Now look, it's giving us this nice, what do we want to call that? Slightly green color. The pieces that are in slightly green will abort when this notices a change. Right now it's polling, right? So 5 times a second, it's going to check to see, hey, am I currently it? And when that changes, we'll just abort the move too. So, here, sorry, we'll take that off again. And now what we should see is we won't have that effect anymore, where after touching someone, the yellow guy keeps moving. Now, again, it's hard to show something that's not happening, but if we ran this enough, we would see that it doesn't happen anymore. And again, if you know how to read the behavior trees, that gets you the information you need. So if I pull this back together, and this one similarly needs to abort there. Right, because otherwise the guy's going to keep moving to a target location even after he's declared to be it. So save everything, go over here, and watch these goofy mannequin guys play tag. Well, I guess I'm it. I better get involved. I hope this was helpful to you. I found behavior trees to be a really neat idea to capture some logic in a really expressive way. We don't have to go in and deal with quite so many state variables and enumerated variables. In Blueprints, we get a nice expressive form. I love the debugging tools where I can pause the execution and look at the state of the behavior tree. Good luck. Happy programming.